So what is the topic of this week actually? Well, as I've told you, the only sources you're allowed to use for true randomness is def random, the view random, or the get random syscall. But wait a minute. My favorite programming language has this nice library called random, and it's exactly what it's supposed to do. I mean, I can say random get rand bits, 128, 16 bytes. I store this in my entropy rand variable, interpret it as bytes, and I have an AES key, right? Because I use the random library, standard library. So most programming languages actually feature functions or modules for randomness. The problem with these is that these are pseudo-random number generators, PRNGs, and they are not random at all. They're completely deterministic, and they are supposed to be used for example, statistical purposes, because they have a good distribution of bits. They're equally distributed, but they're still completely deterministic, so you should never ever use them in a security critical code. But that's one of the very common misconceptions developers have. They think randomness equals randomness, and then they use their standard library's randomness generator for creating random bits, and then use that, for example, as key material or as passwords or as API keys. This is a terrible idea, and this week we're gonna see why. We're gonna look at the most common random number generators and see how we can predict their output in order to predict keys.